Hey Hacksters, today with me I have Joe Barnard from BPS Space. BPS stands for Barnard Propulsion Systems, is that right?
Yeah, that's correct. I named it at the very beginning of when I started it, and having no idea what I was actually going to do. We'll get into all the things that we do, but none of them are propulsion.
But
Yeah,
you do like an amazing range of things. So first a little bit about the group. So you started in 2015, is that right?
that's right. So the fall of 2015, it's just about 3 years now.
Wow, what was your original aim and how has that changed?
So I started it as BPS was sort of like a fake company, and the real project was to try to land a model rocket in the same way that SpaceX have been doing.
Ah,
So I'm sure you're familiar. Have been landing their rockets back on land and on the drone ships out at sea. And the
yeah.
goal was I really wanted to work in the aerospace industry, but I had actually gone to a music school and gotten my degree there for
Oh
college.
wow.
And I couldn't afford to go back to engineering school. And I just figured maybe the best way to do this is if I can demonstrate that I can like teach myself these things, then I could get like taken a little bit more seriously in a job interview. So that was the initial goal.
That's
It
cool.
has since changed, but yeah.
Nice. So then you got into this. I mean, it seems like your hobbies have a way of taking off, right? Oh, literally. But you started this company as sort of a fake way to like help build a portfolio, basically to build legitimacy. And what's happened since then?
Well, all sorts of things. So, like we said, it started in 2015,
Uh-huh.
and it has been just sort of slowly building since. I'll have to send you some links that we can put in like the video description or something. But like for the first year and change, maybe first year and a few months, everything that I did just like failed miserably. So this is just like the nature of experimental learning, and
Mm.
you know, kind of literally trial by fire. And so there's a couple really spectacular,
I just got that.
there's a couple really spectacular failures of some of these rockets very early on. But
Sweet.
let's say, like, I think last spring, like the flights were getting reliable enough, things were getting sort of predictable enough and easy enough to build. Initially, so I design all of the rockets in CAD, and then I print them out on a 3D printer, and I write all the code for them. And in all of that process, there's like tons of ways for inefficiencies to pop up and for things to
Yeah.
not be easy to build. But just by nature of building things over and over again, it got really easy. And so I had been getting a couple of requests from people through the website to, hey, would you like to, would you build a kit so I could build one of these?
Mm-hmm.
And initially it was like, oh man, absolutely not, because it's just so hard to build. Like, how could I ever write up all the instructions for this? But anyway, yeah. So last spring, it sort of got simple enough that I revisited that and I started to make a thrust vectoring kit called Signal. Signal is a thrust vectoring kit for low and mid power model rockets. It comes with like a little thrust vectoring mount, a little gimbal mount, and a little flight computer. This is actually it here. I have one on my desk. Um,
Ooh.
but it's a tiny little PCB that does a bunch of data logging stuff. It looks at the orientation of the rocket and tries to keep it straight up. Um,
And
yeah,
that
and
allows you to launch them more slowly, right?
oh yeah, so this is the other component that I didn't actually realize until well into making this kit is that so model rockets like don't actually model rockets very well.
Uh-huh.
So if you've ever seen like the space shuttle launch or a big Saturn V moon rocket launch, any of these videos, you'll notice all of these rockets, even SpaceX's Falcon 9, it takes so long for it to lift off the launch pad. It's like this majestic thing.
Yeah.
And yeah, but model rockets are really kind of at the opposite spectrum of that. If you've ever seen one of those, they're just
Mm.
gone in a second. And they have to go fast because the fins that are on the model rocket keep it stable.
Mhm.
But if you don't need fins because you have thrust vector control, like the real thing, then you can launch really, really, really slowly, just like the real thing.
That's
So it's
really
all about sort of
cool.
making these models more realistic.
Wow, cool.
Yeah.
Do you think you've inspired any future rocket engineers already?
I don't know. I've gotten to interact with a whole lot of cool people online, though. Like the the community of support has really grown for the project. that's been a huge part of why it's still going, is that there are people who have given me advice or have like provided links to things, or like when I couldn't find, like, hey, my microcontroller keeps resetting, why is this happening? All of these really obscure things. I've definitely built a lot of support online from it. I'm not sure if I've inspired anyone, but
I'm sure you have. So it's still you, obviously. How big would you say your community is? Like, how many people are you kind of interacting with to help build this stuff?
it's hard to judge because it's really just, it's spread across a couple of different platforms.
Mm-hmm.
So on YouTube, there's like a pretty decent following on YouTube. I think we just passed 3,000 subscribers.
Nice.
And I think the same on Twitter, Facebook, and Instagram. It's whatever, but I don't know. Yeah, it's probably in the realm of like 500 to 700 people who like pretty constantly follow the project. And then some of the people who are more dedicated or more like just willing to help, have just more generosity, have actually been supporting us on Patreon.
Yeah.
And that has been just instrumental in keeping this going. Model Rocketry I sell these flight computers now, but model Rocketry is an extremely small hobby, just in terms of, I guess, the market, right? And so
people taking it sort of more seriously than just like, oh, I did this in science class one day.
Yeah. And so the support that a couple of like really generous folks have provided has kept it going.
I love it. And yeah, I actually used to teach kids, and we did a model rocket day, and it's true that it's like a lot of build up for something that like is over in like just a few seconds, like and then you're just like, oh, where is it, are we gonna be able to get it back, where's the parachute, which is fun too, but like it seems so compelling to people to just like see it sort of majestically rise. I'd love to see it someday.
Yeah.
And you don't just make the boards either, you make launch pads and software for it too?
Yep. I think the bulk of the work is the software, really. As it turns out, I mean, like this shouldn't be surprising to me, but as it turns out, writing like rocket guidance software is really hard.
Literally, I'm sorry, no, I'm not gonna make that joke.
Well, so yeah, I think software is the biggest part of it. But yeah, I built a custom launch pad. I tried to put a lot of details on the website about like what I'm building, what kind of sensors it uses, and things like that.
Yeah.
Actually, something that I would actually like to talk about is a new video series that is coming out from the BPS YouTube channel. So BPS, like this sort of company, I mean, whatever you want to call it. It's really, I also say I use the pronoun we to describe BPS, but it's just me. It sounds cooler, but okay. Anyway, so there's this new series coming out called Landing Model Rockets, and for a long time, this little project has existed to sort of showcase my work. And I only recently realized, I'm not sure how, but I only recently realized that like I should be like making tutorials for this stuff. I should be like giving back a little bit. And so the first episode is out now. It's all about flight simulation. It's like 22 whopping minutes long. And we're going to do a whole series of videos on like thrust vector control, all of the like PCB design for rockets. I'm really excited for it. Yeah.
That's so cool.
Yeah, it's going to be great.
Obviously, I love the idea of documenting your process and sharing all of that. And yeah, it is like just you is the like driving force behind this whole community. That's amazing, and like all this stuff that you do. Is this the only thing that you do right now?
Yep.
I mean,
so this is a full-time endeavor. You know, I'm not like pulling in the cash, but it's a full-time thing.
That's awesome. So with both the Patreon that you're doing and with this new video series sort of documenting your process, as well as everything that you've shared in the communities already, this is clearly not like a traditional approach to rocket science. How else do you think you differ from the sort of standard approach to rocketry?
I feel like I have to be careful talking about this because I just want to put the caveat that like these are still model rockets. So there are a lot of things that I can just be willfully ignorant about that won't hurt me at this scale, but like if I was building something much larger, it would be a huge problem.
Like you're not putting little mice on them or anything.
Right, like we're not doing crewed flight, we're not doing anything like that. And the other thing is, I mentioned like I don't do propulsion, so a lot of what's difficult about rockets is, carrying all this fuel on board, and I'm just using little SD solid rocket motors. I guess what's different though is because, so I have like I just learn best through experimentation. That's the way that I can like teach myself the best. And what that means is you have to just fail a lot to like get things to actually work. And you want basically like the lowest cost per failure. So okay, what I mean by that is if I were making my own propellant or making my own rocket engines that are really complicated, that have like turbo pumps and all of this plumbing and stuff, right? Like that failure, like one of those blowing up is a lot more dangerous and a lot more expensive than if I write 1,000 different versions of flight software and they all crash except for one.
It's a time investment, obviously, so that's worth something. But at the same time, you're not losing anything when it crashes. Like,
yeah, or like putting myself in danger or anything like that.
Yeah.
So I guess the difference, if I had to like sum it up, is that I just sort of plan around what am I able to learn by experimentation, and then everything else gets outsourced.
You have all these awesome photos of your development process for the hardware. What would you say were the biggest things that sort of got in your way and you overcame for this?
Let me think about that a little bit. I can actually talk about the awesome photos part. So when I graduated college, about halfway through studying at Berkeley and Boston, I ended up starting to shoot videos. So like as like a career, like getting hired for shooting videos. So wedding videos, music videos, live events, stuff like that. And so I ended up with like all of these GoPros and all of these like nice cameras that when I started doing the rocket stuff really helped development, because like if you record something in high speed, you can usually figure out what goes wrong. I think the hardest thing is like one specific problem that I had to work on last fall, like this time last year. So okay, we can get like way into the weeds on this, but I'm gonna try to keep it light. Okay, so do you know what like a gyroscope and accelerometer are? Yeah, so two types of motion sensors, and
one's
so
for
you
spin and one's for like the direction of acceleration, right?
That's right. Yeah, so you have three axes. I'll use this as an example. So you have like three axes of motion, right? And one detects the rate of change in rotation, and then one detects the rate of change in translation, and that's the accelerometer and the gyroscope. Anyway, basically, like what happens if your gyroscope is only measured, if your gyroscope stays strapped to your flight computer, and then the computer turns this way. Okay, it's very hard to describe this, but like as soon as you rotate one axis and you rotate on another axis, your X and Y axes, like your X, Y, and Z axes are no longer truly in the same reference frame as the frame that you're looking at it.
Right.
Let me think if I can describe this another way. So like if this is your pitch and this is your yaw, right? So if the computer turns this way and then it pitches over like this, it's actually rolling. Like this is actually a roll maneuver. Anyway, that there was a lot of hard math that I had to do around this time last year surrounding something called direction cosine matrices and something else called quaternions. And
I knew it had to do with quaternions.
Okay, so the other part is are you familiar with what gimbal lock is?
I'm familiar with what gimbals are, but what is gimbal lock?
Okay, so gimbal lock is, oh man, I'm going to try to describe this. It's really,
I'm putting your head through your faces.
Yeah, there are a couple of videos that really visualize it well, but basically you have two options for how to deal with that weird problem that I just mentioned. One option is to switch to something called direction cosine matrices, or DCM, and these are, you can also refer to these as Euler angles, and this is the way that we traditionally think about rotations. So you have X, Y, and Z. You have three axes defined as X, Y, and Z, or roll, pitch, yaw, whatever you want to call it. Quaternions are another way of representing that, but they are it's a more complex number, and it is super, super unintuitive. So it's like it's more easy for the flight computer to process it, but it is way harder for the person programming it to understand.
Mm.
And gimbal, the reason that you want to switch to quaternions, which I like tweet about quaternions way too much, but the reason that the reason you want to switch to these is because there's a phenomenon called gimbal lock, where if your vehicle goes over one direction and then another, you can think of like 3 concentric circles as your different gimbals, as your different like sensing on different axes, and 2 of them end up lining up at some point. Like there's a direction you can point your rocket that 2 of them end up lining up, and at that point, like all your control ability is gone from one axis, which is super bad. This is actually something that the Apollo astronauts dealt with too. So when they were circling around the moon and maneuvering their spacecraft, there were points on the navigation ball in the command module that were just like shaded in bright red, because if they were to go near those points, they would experience gimbal lock, and that would be super bad for the mission. So anyway, that is all to say, you can fix that by switching to quaternions, but it requires a whole lot of studying and a lot of really squiggly numbers that look scary at first.
Cool.
Yeah.
That's really awesome. So speaking of the moon, I'm assuming you haven't sent a rocket to the moon. I'm sorry if that's insulting, but what is like the highest that you've sent something and brought it down and retrieved it?
You're correct. I have sent nothing to the moon, as much as I might want to. So yeah, the highest thing that we launched is actually, okay, I don't know if you can see it back there. Well, hold on. I'll just get it up. I'll get it up and show you.
Oh, cool.
So this is
Yeah. I love it. Next to the like plant with the lights on it, you just have this giant rocket. This is so cool.
And it's called, see if you can read what the name is.
Trusty McTrustface.
And then I think I have the motto for it down here too, which is in
trust we trust.
Anyway, so this is what's called a certification rocket.
What now?
A certification rocket. So in the National Association of Rocketry and a couple different organizations, there are different levels of rocketry that you can sort of be certified to fly. So like, I cannot just go out to a rocketry vendor and buy an immensely powerful rocket motor. Like I have to demonstrate that I'm able to do that. The level 1 certification is just a sort of range of impulse and motors that you're able to fly. And that one went up to, I think it was like 300 or 400 meters. It's pretty high. I would love to build bigger things, but bigger things are a whole lot more expensive. So that's why we have things like the Patreon.
Totally. Do you have concrete plans for the future? Do you have any like near-term announcements and long-term dreams?
Sure. I can talk about some near-term stuff.
Sure.
So near-term, this is, okay. So I have this computer. I'm just going to put it up to the webcam here. So this is Signal. And Signal is that thrust vector computer that I mentioned. And then we have a new thing coming out this fall. So this is the side of Signal. And this tiny little guy is called ARC. ARC is what's called a dual deploy computer, which means, so it doesn't control thrust vectoring or anything like that, but you can stick it in a big rocket like that, send it up to, I don't know, 100,000 feet or whatever, and have it deploy your parachutes and log a bunch of data on the way.
Oh, cool.
And so it's this tiny little compact thing. It's got a little SD card slot, got a couple of pyro channels, and it's got, and all of this stuff, by the way, is Bluetooth controlled. So I built an iOS and Android app too.
Wow.
To control these flight computers. Most of like the existing rocketry products on the market operate on like this super frustrating series of like beeps and blinks. You have to like learn a language.
Wow, that's kind of cool, but frustrating.
Well, yeah. So I think it's much easier for it to be just totally Bluetooth controlled. So we've done that for both of our flight computers.
So on the ARC, you mentioned pyro terminals? Is that for like exploding the thing that launches the parachute or what?
Yep. Yeah, that's right on board. Yeah.
Cool.
Signal has 3 of them. ARC has 2. And it's just for exploding different charges or like we call them events on the rocket. So you could separate 2 stages of a rocket. You could light a motor in the air. You could deploy a parachute, all sorts of stuff.
That's really cool.
Yeah,
None of my projects have pyro terminals. Maybe that's what I'm missing.
they're just little MOSFETs. It's nothing crazy.
Oh,
Um, and then you asked about some future stuff. It really just depends on like the amount of support that we can sort of gain. I would love to go bigger and build some larger stuff. So part of that, I think part of that path to getting there is through this series of tutorials that we're coming out with. I think it could benefit a whole lot of people. Lots of folks have expressed interest in like learning these things. And so I think by helping folks out and putting that information out there, we can probably get some more support.
yeah, and you mentioned the education aspect of this, and I imagine, like, I could totally see kids learning about this in school and their parents being like, "Hey, I'm into rockets. Like, I didn't know it was this easy these days." You know.
Well, I
Anyway,
hope, yeah, I think that would be great.
yeah, we're really excited to help spread the word. So this is super cool. Thank you so much for talking with me.
Yeah, thanks a bunch, Alex.
Ah, so cool. Have a great rest of your day.
All right, cool. Sounds good.
Ciao. Wait, do you have like a space motto? Do you say like "Let's ride" or something when you like
Oh,
something?
I'm trying out this new one. It's may your skies be blue and your winds be low.
Oh, that's wonderful. My like personal motto is "Ad Astra, etc." So
Oh, that's great.
I
Yeah.
like yours though. That's awesome. Sweet.
The other,
Thank
the
you.
other, the other good one is space is the place.
Space is the place.
I
That
gotta
is so
say.
true.
Yeah.
All right. Have fun in space.
All right. Talk to you soon, Alex. Bye bye.
Ciao. What kind of music were you doing, just incidentally?
You can actually find them if you look them up. They used to make these. I had like a somewhat successful YouTube channel in high school where I would make like original and cover songs in my basement, and I would like play all the different instruments and then
Wow.
record it and put it together. Actually, I really enjoyed doing that, but I don't know, like kind of indie rock stuff.
Super cool. Do you still
Yeah.
find time to do that at all?
Only a little bit. Like I'll take my guitar out every now and then, but it's mostly just for fun. I'm not making any money off of it.